Welcome in this week Technical Tuesday with CAD-CAM. My name is Marek Pawlus and today I will show you a practical way of using Toolpath drive method. This drive method is available in fixed contour and variable contour operations. It allows us to use other operations toolpath as drive geometry in other operation. For axis roughing, which I will create, is just example application of this drive method. Here you can see a pocket on cylindrical part, which we want to machine using 4-axis simultaneous toolpath. And to make it even more interesting, we will use trochoidal cut pattern. As you can see here, I have already made initial hole making operation. I will use this hole as engage position. We need to create auxiliary 3-axis operation. To do this, I need a planar geometry, which I will create like this. First I will create offset surface of side walls of this pocket. Offset value is 8 mm, which is half of my tool diameter. I'm adding a datum coordinate system, which XY plane defines position of my planar geometry. I will now extend surfaces which I just created. We need to make sure that extension is big enough to create full intersection with XY plane of my datum coordinate system. Now I can create intersection curves. And I will use this planar geometry to create planar mill operation. I will keep it in separate program group as this is not an operation which we want to use in actual machining. This is just an auxiliary toolpath. I will create cut areas as curves and switch tool axis position to on. Now I'll change cut pattern to trochoidal and adjust some of its parameters. And as I'm using pre-drilled hole as engage method, I will change engage type. So here we have 3D auxiliary operation ready. This planar toolpath will be projected on cylindrical geometry, which I will create now. To be able to use operation as drive method, we need to create its CLSF. Now I can create proper variable contour operation. I will locate it beyond workpiece object in geometry view, so I can use my auxiliary cylinder as part geometry. And here is most important step. As drive method, I choose Toolpath, and here I select CLSF file, which I generated a moment ago. I need to select it. Preview of drive geometry looks like this. To create correct 4-axis toolpath, I set projection vector as toward line and tool axis as away from line. And this is all what is necessary to create 4-axis roughing toolpath. It looks like this. I also want to adjust engage options to respect pre-drilled hole. Now we can see how it works in a 3D verification. This is initial hole making operation. And here we have 4-axis trachoidal roughing. What I showed you here is nothing new in NX. Toolpath drive method is available in NX since I remember. The purpose of this video was to explain how to use Toolpath drive method. So keep in mind that this is not the only way of doing 4-axis roughing in NX. We can also use, for example, rotary floor operations dedicated for 4-axis roughing. But rotary floor operations have some limitations in cut pattern types comparing to what I did here. Using approach which I showed you today, we are projecting planar toolpath towards center line of the part, which obviously doesn't allow us to machine the part 360 degrees around. And at the end, let's take a look how this operation will look on a 4-axis machine tool. Thank you for watching. I hope you learned something new about EÞİTİM. If so, then don't forget to subscribe to my channel so you will be updated about my new content. See you in next Technical Tuesday with EÞİTİM.